Hello, I'm Mr. X, Mentor of Mathematics, and this lesson is Trig 105C, de Moivre's theorem. For all real values of this complex number raised to a real number, de Moivre's theorem will hold. So if n is a real value, then this complex number, r times our CIS shorthand business, cosine theta plus I sine theta, that complex number raised to the n power will be the same as raising the r to the n power and then simply multiplying our angle by n. So this is a natural extension of the multiplication we just did in the last lesson of simply multiplying complex numbers expressed in trigonometric form. We're going to use de Moivre's theorem to determine the value of 6 plus 8i raised to the fourth power. Now, simply because I teach all aspects of basic math, I would reach for the binomial expansion to do this. I probably would. Let's start with this. 6 plus 8i raised to the fourth. We're not doing de Moivre's, we're doing binomial expansion, just to show there's another way to do this. Now notice when we have I to an even power, and we'll include I to the 0 power as a 1, we get a real. So when I squared, we get a real, because the I squared is a negative 1. When we have I to the fourth, we get a real, because I to the fourth is 1. I to an odd power stays imaginary. This I will give us an imaginary term, and this I cubed will also make this an imaginary term. And I cubed, if you'll recall, is negative I. So this business right here is the same as negative 12,288I. This is going to be just 4,096. And this is going to be a negative 13,824 because the 13,824 is times a negative 1. So we get this business. I've put all our reals together here, and I times the imaginary coefficients here, and this is what we get. Negative 8432 minus 5376I. And you could write the I in front of the 5,376 if you prefer. Either way is just fine. Now we're going to work the problem according to the trigonometric course that you've come to know and love. Remember that r is equal to the square root of a squared plus b squared. Pretty straightforward in this first quadrant situation here. So, what's theta? Well, we need to get theta, so pick one of these. Let's do the inverse sine of 0.8. And we'll carry it to 4 decimal places. 53.1301 degrees. So we can now write this little complex number raised to the fourth power as 10 cosine 53 and some change plus I sine 53 and some change, that whole thing raised to the fourth power. But what is that? By de Moivre's theorem, we say we can take this 4 and put it on the 10 as a power. That's going to turn into 10,000. And then for our angle, we just multiply the angle by 4. So our 10,000 is out front, and now our angle is the 53.1301 times 4, which is 212.5204. Well, we're going to use a calculator to get these numbers. I won't punch up the calculator. You could do that on your own. So we get this number for the cosine of 212.5204 degrees. We get this number for the sine of 212.5204 degrees. And what makes this really nice is that we have a 10,000 out front. So when we multiply these numbers by 10,000, obviously we move the decimal point 4 places. And we get this, which agrees with the result we got from binomial expansion. Now this is not a lesson in binomial expansion, it's a lesson in de Moivre's theorem. So we're going to let you do one. Pretty straightforward. Remember, you can draw the thing and get basic relationships, and then apply de Moivre's theorem, and then solve algebraically with a little help from a calculator. Or you could look the values up in tables. I'll tell you, if you use the tables, you'll probably get just something slightly different. You might be off by 1 or 2 on these numbers from rounding error. Okay, let's finish Trig 105 with a little quiz. Use de Moivre's theorem to find the following complex value. Express it algebraically. Square root of 2, square root of 2, this length is 2. What's the angle? 315 degrees. Or if you're in radians, theta would equal 7 pi over 4. I'm going to keep it in degrees. I believe that's what we're dealing with. And what we can do is we can expand that to say that's equal to 2 to the 7th times the cosine of 7 times 315 degrees plus I sine the angle that is 7 times 315 degrees. Alright, what have we here? 2 to the 7th, that must be 128. Cosine of 2100 plus 105, I believe that'd be 2205. Actually, we don't need these parentheses. I tend to write them, but you don't need them. I could put parentheses around this, but we really don't need them in this case. We know that it's a cosine of this angle, and that's a number, and I times this number, which is the sine of 2205. I'm going to take off 1800 degrees because I can do that mentally. If you understand that 360 times 5 is 1800, then we could reduce this number by 1800. Actually, there's another 360 to go. I'm doing this in one extra step. Now, in order to get the numbers we're interested in, we're going to subtract another 360. Let me fudge a little bit with the eraser here. There we go. How about that? Really shouldn't have this space in here, but you know this is 45 degrees. 405 minus 360 is 45. So we just bring it home. 128 times the cosine of 45 degrees plus I times the sine of 45 degrees. And that, ladies and gentlemen, is that. Remember, you have to write it the way your teacher wants it. Some people want it like that. And some people, including the author of the first trig book I used in high school, preferred it like that. Doesn't really matter. Suit yourself. We hope we've added to your enjoyment and appreciation of the language of mathematics, particularly this piece of the language called trigonometry. We want you to have the very best in this life and live life to the fullest and live long and prosper. May God bless you.